On behalf of the Virginia Renewable Energy Alliance, I'd like to welcome you to today's event. My name is Sarah Cosby, and I serve on the board of the Virginia Renewable Energy Alliance as their vice chair. I'm excited to welcome you to today's event. If you don't know VA-REA, we are the Virginia Renewable Energy Alliance, and we consider ourselves a big tent clean energy organization, and one of the main elements of our mission to advance clean energy and renewable energy in Virginia is education, outreach, and networking. And to carry out that element of our mission, we have a series of events throughout the year. You've dialed in today for one of our LEAD series events, and LEAD stands for Leadership in Energy Advancement and Development. We try to do those events once or twice a year, and we're pleased today to have our first event focused on nuclear. And before I get started on that event, I wanted to also talk to you about our marquee event for the year, which is the Virginia Clean Energy Summit, which takes place on October 20th and 21st. And we would welcome you to register and join us for that event. It will be in person this year at the Greater Richmond Convention Center. And I will put in our chat today some links where you can find more information, and we certainly hope you will register for that event. And before we get started, I'm also going to give you a few housekeeping pointers. Today's event is going to be moderated, and the moderated discussion will last roughly an hour. At the end of the moderated session, we will be happy to address questions from folks who have dialed in to participate. And you'll see at the bottom of your screen a Q&A option and a chat option. If you would try to put your questions in the Q&A, we will pull from there and answer as many as we have time. If you do happen to put them in the chat, we'll try to find those as well and get your questions answered. And so without further ado, I would like to now introduce our moderator and panelist. Our moderator is April Wade, and April is the executive director of the Virginia Nuclear Energy Consortium and founder and president of Wade Strategic Communications, a public affairs firm. As the executive director for the Virginia Nuclear Energy Consortium, April represents the nuclear industry in the Commonwealth, advocating for additional opportunities in commercial power, nuclear medicine, academic research, and defense applications in nuclear energy. April's company, Wade Strategic Communications, works with corporate and nonprofit clients to develop goal-oriented strategies for navigating the state and federal policy processes and communicating with stakeholder audiences. In more than 20 years as a public affairs practitioner, April has worked with clients ranging from oil and gas services firms, nuclear power industry, rare earth mining, local and county governments, and women's causes. Prior to founding her company, she served as the communications director for the Louisiana Energy Services on the National Enrichment Facility, the first major nuclear facility to be licensed in more than 30 years and the first ever to receive a combined construction and operating license from the NRC. We are very fortunate to have 4 very talented panelists with us today. And I'm not sure how you're showing up. They're showing up on your screen, so I'm just going to take it from the notes I have in front of me, and I'll start with Dr. Erin Totemeyer. Dr. Totemeier is an expert in nuclear fuel technologies. He's with Lightbridge Corporation, So he's an expert in nuclear fuel technologies, radiation damage, and the nuclear fuel cycle. He joined Lightbridge in 2008 as a nuclear engineer and is currently the Vice President of Fuel Cycle Technology and Fuel Fabrication. Dr. Totemeier provides strategic and technical oversight for Lightbridge's nuclear fuel development activities, and he provides strategic advice on nuclear power projects for Lightbridge and its partners. Dr. Totemeier was appointed to the Small Modular Reactors Working Group of the U.S. Department of Commerce International Trade Administration in 2022. Dr. Totemeier earned a Bachelor of Science and master's degrees in nuclear engineering at Purdue University and a PhD degree in nuclear engineering at Texas A&M. Next, I'd like to introduce you to Jon-Michael Murray. Jon-Michael is with the Clean Air Task Force, and he is their nuclear policy manager. He's responsible for developing and advocating for policies that promote the development and deployment of advanced nuclear energy technologies in the U.S. and globally. Before joining the Clean Air Task Force, Jon-Michael had prior roles at the U.S. Department of Energy and at the U.S. International Trade Administration. He also helped develop a course for financing and deploying clean energy at Yale's Center for Business and the Environment, and has served as the EDF Climate Corporate Fellow supporting Maryland's Port Administration's Clean Air Program. And prior to all of these roles, Jon-Michael served as a nuclear operator in the U.S. Navy stationed on an aircraft carrier off the coast of Japan. Next, I'll introduce you to Scott Rasmussen with NuScale. Scott joined NuScale as Director of Sales in September of 2018 and is responsible for all aspects of developing domestic and international customer partnerships to implement NuScale's SMR power plant technology. This followed an extensive career at GE Power and GE Hitachi Nuclear Energy, where he last held the position of Vice President, PRISM product line nuclear plant projects. During his time in GE's power division, Scott gained experience working with global power plant developers and utilities and has supported numerous large power projects in the US, Europe, the Middle East, Africa, and Asia. Scott has also spent time in various engineering and leadership positions in commercial operations and project management and supply chain. Scott holds a Master's of Science degree in mechanical engineering from Union College and a Bachelor of Science in Aerospace Engineering from the New York Institute of Technology. And last but certainly not least, we have Todd Flowers, who is Director of Business Development at Dominion Energy, which is also the company where I work. I may have failed to mention that in the beginning. Todd is Director of Business Development, as I mentioned earlier, at Dominion. He is responsible for leading the regulated power generation business development team, which includes the development or acquisition of power generation projects, including renewable, nuclear, and fossil fuel facilities, with the development or acquisition and the development and acquisition of energy storage projects. Preceding his role in regulated power generation, Todd supported the acquisition of solar projects across the country that are now part of Dominion's unregulated merchant power generation fleet. In prior roles, Todd worked in Dominion Energy's nuclear business unit as the supervisor of fuel project engineering and served in various roles within nuclear engineering. Todd holds a Bachelor of Science degree in physics from Longwood University, a master's in nuclear engineering from the University of Virginia, and a master's degree in business administration from Virginia Commonwealth University. April, I'm going to now turn it over to you.
Thank you, Sarah, and thanks for having me today. As Sarah mentioned, I am the Executive Director for the Virginia Nuclear Energy Consortium, shorten it to, we call it VNEC. VNEC is a unique organization. It is a partnership between industry and academic institutions. We were established in 2013. It was established by legislation that was passed in 2013 that created the Virginia Nuclear Energy Consortium Authority, VNECA. The legislation directed VNECA to establish a VNEC, a nonprofit entity to address commercial, industry, and policy issues and conduct day-to-day activities to promote the industry. The authority, the governor appoints members to their board. Our board we're a nonprofit organization, so we have membership fees. Our missions are the same, and I report to all our activities to the authority on a quarterly basis. My board members include representatives from Dominion Energy Services, Framatome, GE Hitachi Nuclear Energy, Liberty University, Lightbridge Corporation, Newport News Shipbuilding, NuScale, University of Virginia, Virginia Commonwealth University, and Virginia Tech, and Framatome. We focus on promoting Virginia's nuclear assets and capabilities, economic development opportunities, workforce development, and we advocate for the industry, which includes research and development and innovation for advanced technologies. I'm looking forward to today's panel and want to thank our panelists for joining us today. Before we get started, I want to give the panelists a moment to introduce themselves and their organization. Scott, will you start us off?
Sure, thank you, April. So first and foremost, Scott Rasmussen, Director of Sales with NuScale Power. And though NuScale is headquartered in Portland, Oregon, we're really a distributed workforce and distributed team around the country. As a longtime resident of Virginia since last year, really happy to be here today and also bring forth some of the, I would say, the direct challenges that Virginia faces. And we've been working with a number of folks to get there. NuScale's sole focus and sole purpose for being is to really change the power that changes the world. Nuclear energy has that potential to change the dynamic in the world, and NuScale has really developed the technology in small modular reactor space to change the paradigm in nuclear energy. Our key area, I think, is a focus that we've been working on for several years now that's really become paramount to moving the US forward in, I would say, energy security and clean energy implementation, is taking a look at existing coal-fired or coal plant facilities and determining how to reutilize those resources, the plant itself, the people that work there, the communities, to really turn that into a clean energy powerhouse with SMR technologies. And there's a lot more that goes with that, and that I think we'll get through during the discussion today. But again, happy to be here today, and really, I'd like to looking forward to the opportunity to help Virginia to move forward. Thank you.
Erin?
Yeah, hi, April. Thank you for the invitation, and thank you to Sarah for the introduction. I'm very excited to see Virginia leveraging its long and successful history in the nuclear industry to lead the nation on deploying new nuclear power projects as we continue to transition to clean energy sources. As April said, my name is Erin Totemeyer. I'm the Vice President of Fuel Cycle Technology and Fuel Fabrication for Lightbridge Corporation. A little bit of background on myself. I started in the nuclear industry in the year 2000 as a reactor core analyst, sitting in a little cubicle running computer calculations, making sure the cores I was responsible for were run efficiently and as safely as possible. I learned a lot during that time, but I think the lesson that stuck with me the most was just how extremely dedicated and determined and thorough America's nuclear workforce was and still is today. And I knew from that point on that it was an industry I'd be proud to be a part of. That experience led me to the path of fuel development and fuel cycle technology. I realized that fuel is one of the components of the nuclear power plant that tends to be the most limiting in terms of how much power you can get out, how efficient you can run the power plant. It's also the component that we have to deal with long term in terms of spent fuel and long-term radioactive waste storage. So I was very fortunate to go into graduate school and worked with some universities that focused on that type of research. Now I'm with Lightbridge Corporation, which is based in Reston in Virginia, Northern Virginia. And we're developing a new type of fuel for water-cooled power plants, which enable improved efficiency, improved power output, improve safety and enhance proliferation resistance for the existing fleet of commercial power plants, but also some of the new power plants that are being developed today that are water cooled, like we'll be talking about today within the SMR realm. So very excited to be a part of the panel and looking forward to the discussion with everyone today.
Thank you. Todd?
Great, thanks, April. And I want to thank the Virginia Renewable Energy Alliance for having this panel today. As a nuclear engineer, it's very exciting to speak to such a wonderful renewable energy group. Having served in both capacities in nuclear in the last 8 years, primarily in the development of renewable energy projects, it's very unique to have nuclear now a part of this discussion. So thank you for hosting the panel. As April mentioned, I'm the Director of Business Development, and the really unique thing about my role is that we're responsible for really deploying an extraordinary transition that we're in. I don't think our economy has seen quite this type of transition to clean energy technology since the Industrial Revolution. Certainly very exciting times. And if you look at what my company has done as recently as 2005, we have cut our carbon emissions by approximately 43%. And we've really just gotten started. So it's certainly an exciting time to deploy new technologies, to build and deploy both utility scale and distributed solar projects, to move forward with our offshore wind project, and to really advance new nuclear as we evaluate the opportunity that small modular reactors present. So thank you again for having me in the panel, and I look forward to our discussion.
Thank you. Last but not least, Jon-Michael.
Thank you, April. As Sarah mentioned, I am the Nuclear Policy Manager at the Clean Air Task Force, or CATF, and we are a non-traditional fact-based environmental organization that builds momentum for solutions based on scientific evidence, intellectual integrity, and pragmatism. And we recognize that the climate change and the demands of a modern society are very complex challenges. And so that's why we think that we can't limit our tools, as we approach those obstacles. And that's why, and we think that nuclear is a very important tool alongside renewables. And so we're very excited that Virginia wants to engage in this discussion.
Well, thank you guys. I really appreciate it. I'm glad, excited to have you all here today. And I just want to remind everybody, this is a conversation. So please, I want everybody to be engaged as much as possible in the conversation. So we're going to start off. What are SMRs and how are they different from the nuclear power plants that we see today here in Virginia? Who wants to start? Scott?
I knew you were going to throw that at me, so thank you. So SMRs, the direct definition, small modular reactors. And what does that really mean? So the definition over time has really been aligned with a reactor that can produce enough energy to deliver about 300 or less megawatts of electricity. When you get very small, down into the 50 megawatt or so, it really kind of migrates into what's called the micro reactor space. So small, 300 megawatts of electricity or less, modular, really sized to be built in factories or components that are factory developed that can be shipped to site. I'll focus on NuScale's technology, which is completely factory built and shippable, either assembled or in a series of components that can be not manufactured, but just assembled on site for implementation. And the goal of SMRs really across the board and all technologies with all companies is to be able to have that repeatability of quality, efficiency, and really cost effectiveness from the reactor development and reactor delivery perspective to sites. So I think that's the focus of what it really is. But what does it mean going forward is the ability to have a powerful energy source that can fit on a number of sites. So again, a 300 megawatt reactor site can be relatively small. And that's not something that we're used to in the nuclear industry. So this is an exciting opportunity to really bring nuclear to a large number of facilities and communities and provide clean energy 24/7 for 60, 80, 100 years.
I would just expound on that a little bit, April, and say that many of the small modular reactors on the horizon include, almost all of them include several new advanced features that our conventional large reactors don't currently use, things that they're going to allow for new applications and enhance safety and efficiency.
So, and I just wanted to make sure there's another term that's out there, because there's a lot of things going on in the nuclear industry right now. What is the difference between, and I think you touched on a little bit, Jon-Michael, but do you want to touch on a little bit more with SMRs and advanced reactors? Because that is also on the table of conversation.
Sure. I mean, this is a short explanation. As Scott mentioned, small modular reactors really are a category based on size, whereas advanced reactors are based on some of the more advanced features that they include. As I mentioned, some of those inherent safety features. So this is like walk-away safe technologies where even if the plant's lost all electrical power, the reactor core would still be safely cooled.
So I think Jon-Michael is trying to get a job at NuScale by taking some of our taglines and using them right there. That is a key feature of NuScale technology and a focus for many SMRs. But there's a blurring of the lines there between small modular reactors and advanced reactors because of the size and because of capability. I did want to chime in one thing though. Advanced reactors really kind of tend towards getting out of the traditional light water reactor technology, using advanced fuels and advanced coolant systems that are, I would say, that next generational step beyond what we currently use in the US fleet. That doesn't, I mean, I don't want to make it sound like, well, they're not operational. No, a lot of them have been tried and true tested throughout history within the United States. Let's not forget, the US is the birthplace of civil nuclear. And so we've got a ridiculous amount of experience really in a number of technologies, but a lot of those were just not commercialized, and they weren't commercialized for several different reasons. And one of them was just because of the manufacturing capabilities within the global supply chain, US supply chain and global supply chain. But over the last 60 years or so for the US nuclear industry, that's changed. And so now there's opportunity to bring these advanced reactor technologies forward. I look at, again, I just focus on NuScale for a moment. I look back at the factory development and the manufacturing capabilities of 10 to 20 years ago. Our design probably couldn't have been built. But here we are now, and it's not just could be built, it's actually being manufactured now. We're going through all the manufacturing trials and all the details to bring that forth. So I think that leads to another question of when will SMRs be available?
Well, we're going to get there. We'll get there.
I don't want to jump the gun on you.
And I would just tag on to that again and mention that, within this category of advanced reactors, which is a subcategory of small modular reactors, though advanced reactors don't have to be small, not all of them are. They also allow for, as I mentioned, these increased applications, new types of applications based on different types of operating parameters. So, for example, many small modular reactors can operate at much higher temperatures than conventional reactors. So that allows for new technological options like pairing with hydrogen production, for instance, or industrial process heat.
Excellent point. Thank you for making that. I appreciate that.
Thank you. Does anyone else have anything else to add to that, or I can go to the next conversation? Todd?
Yeah, April, I'll just add to what Scott and Jon-Michael have already discussed. But I think, a big thing that distinguishes SMRs from your traditional centralized nuclear power plant, one is the siting flexibility that you don't have with a traditional nuclear power plant. Given the footprint, you don't need 2,000 acres You can site these in locations that traditionally we've not been able to site nuclear power plants. This could be locations where former coal power producers were located, could be other brownfield sites. Given the emergency planning zone, you can place them in areas that have a higher density. So the siting provides a great deal of flexibility on where you site these reactors. And secondly, and this is an item that has historically kind of tarnished the industry, is can you build these on time and on budget? And that is why we haven't seen a great number of the larger centralized nuclear power plants built in this country, because we've not been able to do that. And SMRs present us with an opportunity, because they're fabricated in such a way in a manufacturing plant. You have more control over those components being built. You actually construct the components in a factory setting with great control. You deliver those components on site and you assemble them. So you're not constructing a plant on site. So you have more certainty in both your construction timeline and your cost. So with SMRs, we truly have the opportunity to demonstrate that we can build new nuclear power plants in this country on time and on budget.
I just want to follow that up with Todd. That's an incredibly important point. So thank you, Todd, for making that. The on time, on budget. If we can't get there from an SMR perspective or a nuclear perspective, then it's just a great idea that's just not implementable. And we've not done the industry or the country or the world a service at all. And it can't be lost, the value of really factory manufacture. You build the components and you ship them. I came out of the aerospace industry, and I liken it to the same thing with and I've worked for some major aircraft players. You don't deliver components of an airplane to an airport, you deliver the plane. And that's exactly what we're trying to do. You deliver the reactor to the site and it gets installed. And it takes all the quality, all the effort, and all of the I would say challenges of the traditional large reactors out of the equation, and you put it into a controlled environment in the factory for repeatability. And I really focus on the quality of that. The better the product, the more the more cost effective it becomes by shipping it out that way.
Thank you, guys. This is a great conversation. So this leads me into, since we have so much wind and solar and it's advancing, and there's more of it's coming up every day, why do we need SMRs? I know you all have an answer.
Yeah, and I can start at least from a Dominion Energy's perspective, because we're certainly deploying a tremendous amount of solar, offshore wind, energy storage. And as you decarbonize the grid, system reliability is critically important. And we have to balance the grid 24/7. So having these resources available that can be delivered energy when it's called upon is important for system reliability. And SMRs provide us an opportunity to really develop a carbon-free resource to complement the renewable generation that we're already deploying on the grid, to ensure that we have grid integrity and grid reliability. Not only does it give us that system reliability that we need, it can do so economically. And if you compare the amount of cost associated with deploying, say, solar and energy storage, if you need energy on demand, given the capacity factor of solar and the efficiency of energy storage, you really need to overbuild those systems. If you want to deliver, say, 100 megawatts of energy around the clock, you would need to build at least 400 megawatts of solar and energy storage. So if you compare the levelized cost of energy of deploying that scale of renewable energy and energy storage, SMRs are expected to be very cost competitive and likely the least cost option to deliver carbon-free, on-demand energy for our customers. And that's one of the primary reasons that we're evaluating SMRs. And if you look at our integrated resource plan, for the first time ever in history, SMRs are now included as an available resource as we do our long-term planning.
And if I can add to that, April, SMRs and nuclear in general are also very important because they are energy dense. And I'll explain why that's important, because there's a couple of implications. So number one is land use. A single uranium fuel pellet creates or holds about as much potential energy as an entire ton of coal. And likewise, the amount of power land required to produce the same amount of energy with wind or solar are orders of magnitude larger. And so as we continue to build out renewables, which are important, we are going to run into, and we're already seeing this happen, we're going to run into land constraints in addition to permitting issues and lack of social acceptance, just because of the incredible amount of land used. And land is a valuable resource that can be used for other, economic and social purposes. And then also the energy density is very important, because what is often left out of projections in energy modeling and otherwise are the incredible amount of energy that we're going to use in the future as our society continues to modernize. So we look at things like data centers use an incredible amount of energy, cryptocurrency, and then also from a global perspective as well as a state perspective. As economies modernize, especially in the global south, we're going to use a lot more energy, and we need dense energy sources to achieve that, because renewables just won't be able to do it alone. And there's a lot of recent analyses that have confirmed that clean, firm power is going to be very important to moderate the cost of variable resources, as Todd mentioned, and also to minimize the land footprint.
So April, if I could add again, I want to thank Todd and Jon-Michael, excellent points. And energy density really can't be minimized in this discussion. One of the things that it really is one of the things that we focused on with NuScale, and most SMR providers do. As an example, a NuScale plant, we call it a Voyager 12, where there are 12 NuScale power modules in an array within a reactor building on a singular site. So think about it, 12 reactors on one site, and that site operationally is less than 100 acres. Less than 100 acres, and that plant puts out 924 megawatts gross. That's an awful lot of power on a small footprint. Now, granted, you'll need a little bit more space during construction, but you can turn some of that laydown area and that back into green space over time or utilization for other things. And as Todd was saying too, with really having this integrated approach of clean energy sources, wind, solar, nuclear in general, and in the form of SMRs, it's the ability for all of those to work together. And one of the things that SMRs can provide is the ability to really load follow quickly. And NuScale's technology, and again, I'm trying to be careful not to talk on behalf of another technology and say something that might be inappropriate. So I'll just focus that way. Really have the ability to load follow, which means when the demand is high, we can increase quickly. And when demand drops off, because there's a lot more solar and wind at the moment, we can bring back down and really stay in a position of like a hot standby to be able to cycle quickly. It's nothing like I mentioned before, I live in Southern Virginia, and we can go from being bright sunny day like today to overcast and zero solar energy provided in about 30 minutes. So that means I've got to have an energy resource that can really cycle. You almost think about it of having a whole house generator. When the power goes out, it turns around on a dime. It starts up quickly and provides you the energy you need. And that's the same thing that SMRs can do to really help balance out and to really ensure stability of the grid, and that everyone has the energy they need whenever they need it.
In April, if there's anything that the energy crisis in Texas taught us a couple of years ago, it was the value of having a diverse supply of power generation in your system.
Another thing I'll add to that, Todd, is I think California just last week also just told us again how essential we need to have a diverse energy sources. So next question I have for you guys, as we talk about SMRs, and another topic, a word that is used often is HALEU. Can you all explain HALEU to the group?
I'll take that one, April, to start with. So within nuclear fuel, the low enriched uranium, LEU, is what we commonly use for our commercial power plants today. For those not familiar, try not to use too much jargon. The fuel that we take out of the uranium we take out of the ground has a very small amount of uranium-235 in it. And that's the component of the uranium that fissions and gives off the heat that we turn into power and electricity. So the enrichment process increases that uranium-235 concentration up to about 5% for our commercial power plants today. What's referred to as HALEU or high assay LEU, it just increases that enrichment up to about 20%. So you end up with more fuel, fissionable material, fissile material in your fuel, and the density of that fissile material is higher. So what that allows you to do from a reactor design and power plant design perspective is get either more power out of the same amount of fuel, extend the lifetime of the fuel, and run, design the fuel and the reactor to operate in modes that you can't with the typical LEU fuels. So we're hearing more and more about that today, as many of the advanced reactor developers, including advanced nuclear fuel developers like Lightbridge, are looking to leverage that HALEU material to design even more efficient reactors and nuclear technologies to achieve all these benefits that we're talking about with SMRs. We want to make sure that the next generation of power plants can really take those benefits to the next level and ensure that nuclear is providing the most efficient and most reliable and cleanest, safest form of power that we have available. The caveat with that right now is that America does not have a domestic supply of HALEU. We as the nuclear industry and the advanced nuclear development community are working very closely with the Nuclear Energy Institute and the Department of Energy within the U.S. to get some funding and motivation and progress on demonstrating that HALEU supply chain. But it's a big effort, and a lot of work remains to be done there.
Thank you. I really just want to make sure the audience gets a clear picture of what all these terms that are being used right now as we talk about the nuclear industry. So one of the things I want to talk about next is what's changed in the nuclear industry. Why are we, 10 years ago, could we have done what we're doing now, not just on the technology side, but just on people understanding what the nuclear energy is?
I'll start this off, April. Well, first I'd say that public perception, I think, is coming around. I mentioned some of the recent analyses that are confirming that renewables can't do it alone. We need to have options, and we need to have dispatchable firm power options. And so nuclear very clearly fits that role. But also, on the back of that changing perception, there's been significant development, on the backs of hard work done by organizations like NuScale and others to revolutionize the business model of the nuclear industry. It's often come down to cost, and so NuScale and others are developing these new business models around modular development and manufacturing processes that will make nuclear much more economical. And then also, as the public opinion and support for climate change measures increase, there's a lot more incentive for nuclear, especially if we consider, for instance, the recent IRA, Inflation Reduction Act bill, which included significant incentives. And these are also happening at the state level, including in Virginia.
April, I'll kind of piggyback on Jon-Michael. And if you look at 10 years ago today, or when I started my career, coal was king, and wow, have things really changed in that time frame. But even as recently as 10 years ago, two key things are different today than I would say a decade ago. One, I think we fully understand the importance of decarbonizing the grid. And that's happening in every sector of the economy. So it's critical that we decarbonize. I think everyone understands that climate change is real, and we need to make significant major changes, and we need to take them now. we know that we need to have a source of energy to complement renewables. You can't get there by renewables alone, as Jon-Michael mentioned. So in addition to decarbonizing the grid, another kind of near-term concern is energy security. And with the geopolitical situation that we're in, you're seeing perception change for nuclear across the globe, especially in Europe, that have relied upon sources of natural gas that may be turned off at any point in time. It's recognized that energy security is critically important. If you compare the need for energy with the need to decarbonize, nuclear has to be a part of the equation. You cannot get to net zero without nuclear.
And if I could follow that up too, April, both Todd and Jon-Michael make, again, excellent points. And the concept of energy security, it used to be almost a little bit of a theory, if I can, not to minimize, but that was kind of part of the primary point of the discussion, was that it's an idea that we need to worry about tomorrow. Well, the change of events at the beginning of this year have certainly provided impetus for Europe to really start focusing on how to move away from being beholden to other countries for their energy needs as they move forward. And, really, I think part of that too is this confluence of events of climate change and a focus on that, general change in public opinion on nuclear energy, which is really improving over the last 5 to 10 years. So it used to be negative, then it went neutral. And I do think it's really taken a spike in a positive direction over the last couple of years, really combined with the need for security of supply for clean energy has really moved the needle. And the United States is poised to be leading that effort globally. And we can talk more about that in a few moments.
And I just like to make one last point on this, on a policy point. As all this momentum gains for climate action and energy security, there's more recognition of certain barriers, kind of artificial barriers that have limited innovation in the nuclear sector, and that have been partially responsible for some of the high costs. And now we are addressing some of those.
And April, I'd add, great comments from everybody on the panel, but I think in terms of what's changed over the last 10 years, one thing that we can't discount is the large influx of financial support for new nuclear, both private equity and U.S. government support. Investors have realized that we need the benefits of a decarbonized grid, and if they want it to come to market, they've got to support it with real dollars and real long-term investment. For a long time, folks were hesitant to invest in nuclear because it is a long development cycle. There's no guarantee that you'll get through to the end, but I think we've seen a big change in the last decade on the willingness to put real dollars behind new technologies.
Thank you all. Jon-Michael, in your comments last, you mentioned something that I think that we need to talk about next is, what are the barriers? We've talked about the positives, but what are the barriers on deployment of an SMR?
That's a very good question, April. And there are barriers across the nuclear fuel cycle, so all the way across the supply chain, and I'll cover a few, but one of them is a regulatory. So and this is primarily a federal policy issue, but we are working with the NRC now, which has a mandate already from Congress to develop a new rule for licensing advanced reactors, and that's a challenge that that a lot of organizations are working on, and we will overcome. But that's one barrier. Other barriers are not necessarily policy, but around public perception. There are several states, for example, that have, because of certain perceptions, have moratoria or bans on building new nuclear. So that's one thing we like to see change, and that's not the case in Virginia, thankfully. And there are export barriers. There are barriers around storage of partially burned fuel. Those are again mostly national federal policy barriers, but we're working on those as well, and we will overcome those alongside the other challenges.
And April, I'd like to, and I agree with everything Jon-Michael said, but all those barriers that he mentioned, they're opportunities. So if you look at supply chain and lack of supply chain, well, that's an opportunity for the Commonwealth of Virginia to introduce new manufacturers, to expand existing fuel fabrication opportunities we have in Lynchburg. Supply chain issues, I think, can be resolved. It's going to take investments and innovation and technology, but that's an opportunity. You look at workforce, yes, it's a barrier. We have an aging nuclear workforce. However, we have, a great number of folks supporting the fossil fuel industry and supporting coal power production at those plants. So it's an opportunity to transition those careers into the nuclear workforce. So each of those barriers, whether it be workforce development, whether it be supply chain, whether it be innovating new technologies that use nuclear fuel as a fuel source for power generation, concepts that Moltex is investing in, I think each of those barriers can be turned into opportunities, not only for the Commonwealth, but also across the US.
I'm going to chime in with what Todd just said, because I could not agree more that I like hearing Jon-Michael's list of challenges, but I look at those as opportunities. And I think Todd is absolutely right. One of the things I think that's important for SMR and nuclear technology companies like NuScale to bring forward is how to really consolidate and really bring down the number of required nuclear grade components in that, and really leverage industrial grade components where there are a number of suppliers throughout the supply chain that can provide that, both in the US and Virginia. And we work with several of them. And it's bringing that down, but also really kind of promoting the concept that a nuclear power plant needs an awful lot of standard type commodities. The number one commodity on the list by cost, when you look at it, is labor. And so what that really means is skilled labor force to be able to deliver a power plant. Think about it, a power plant of any kind. You need pipe fitters, you need qualified welders, and all these folks in these roles have to be qualified, electricians, etc. Now, building up that workforce really supports not just SMRs, but really any number of implementations of energy, etc., but particularly for going into the clean energy route. So I always kind of zero in on the non-nuclear components, because people get a little leery of the cost and the investment necessary to develop the supply chain for that. But the majority of it is non-nuclear. And how do we develop that? We've got the resources here in Virginia, and I think we need to take that opportunity to expound upon their capabilities to deliver.
Well, I'm just going to take a moment and plug Virginia a little bit. Virginia, there is no, it's both, I think everybody pretty much has mentioned something about Virginia in that last little bit, but there's no other state like Virginia with what we have with the shipyards, what we have with BWXT and Framatome manufacturing, what we have with Dominion with the nuclear power plants at Surrey and North Anna, what we have with new companies like Lightbridge here in Virginia. We just have a lot going on in Virginia, and plus our universities. We're very unique in what we do have here, which is exciting today, because this is why we're having this conversation here today. And one other thing I'd like to mention about workforce, which you all have brought up, which is definitely always a topic of conversation, is that another way Virginia is unique is what we have is called the 17th career cluster. That is where if a student is looking at getting into energy jobs, they actually can find a pathway for energy jobs here in Virginia, regardless of what nuclear, wind, solar, you can do that here in Virginia. There's only I believe 5 other states that have that. We're the only state that did that by legislation. So these are just little plugs that I like to talk about with Virginia that makes us really unique. And that's why we're having this conversation today, because we do have the background to have an SMR here in Virginia at some point, and we definitely have the knowledge. So the next question I have for you all.
If I can.
Yeah, please.
I would like to point out that Virginia actually has the highest concentration in the world of already operating small modular reactors. At any given time, there are about 20 small modular reactors in Norfolk Naval Shipyard on the submarines and aircraft carriers. So you have a long history of it.
Another fact, the first commercial reactor was actually in Virginia as well, at Fort Belvoir.
Hey, if we're throwing out unique facts about the Commonwealth of Virginia, it is also the home of the only domestic supplier of research reactor fuel elements for colleges, universities, and national laboratories, and the fuel fabricator for our nuclear subs and our aircraft carriers. So really unique fuel fabrication facility opportunities right here in our home state.
Well, awesome. I love plugging Virginia. So the next thing I want to ask you all, and it was brought up a little bit too, is about the NRC and the regulatory process. What is different with how the NRC has licensed prior reactors, the models that are up and running right now, to what reactors that we're looking at for the future?
I'll jump in. I'll jump in with that.
I say Erin. I'm gonna let Erin go first. I'm gonna let Erin go first this time.
Well, I am not a reactor developer, nor is Lightbridge. We're a fuel development company, but I guess I would say from our experience with the NRC, the NRC is of course going to do its job to ensure that America can enjoy the benefits of nuclear technology while protecting the people and the environment from harmful effects of radiation. That said, the small modular reactors, because they are so much smaller, and the power plants are designed differently and use advanced safety practices, passive safety systems. They've got different operating regimes, all these things we've been talking about. The NRC has to take a different look at how they approach licensing these things. Of course, they have to meet all the regulations that are in place, but how those regulations are met can be different. Things such as we talked about, where are they sited? Are the emergency planning requirements and emergency planning zone requirements the same, or can they be different? Plant security, smaller power plant, less material on site. Can you have a smaller security force in place? Even so far as insurance and liability associated with the plant have to be looked at, through a different lens for some of these smaller reactors than we do for the large centralized power plants. I guess maybe Scott, since NuScale is the first company to get a design certification, maybe you can comment a bit on your experience with the NRC and licensing an SMR as someone with firsthand knowledge.
Well, then to jump in front of Jon-Michael, so thanks, Erin, and you're right. All your comments were absolutely right, and things that we experienced with NuScale and going through that process. One of the things is the biggest thing I think was really a paradigm shift with the Nuclear Regulatory Commission to go from thoroughly understanding the large monoblock type units and plants and how to really analyze those and how to ensure safe design, safe construction, and safe operation, and be able to manage that. And they really kind of got stuck into that paradigm. So I would say that the majority of the effort from NuScale to get its design approved was helping to break down those barriers and look at the regulations from a different perspective, not changing the regulations, but really looking at it from the view of it's a different type of a reactor, size-wise. The components are all it's a pressurized, NuScale is a pressurized water reactor, which is operational, as you was mentioned before, on Navy ships and in large nuclear power plants to the US and the world, but it's done differently. And how do you get the NRC to see it that way? Also, while doing that, you really have to bring forth modern techniques for analyzing, review, and approval through probabilistic risk assessment and thorough design review. It can't be lost. I think a lot of people think that NuScale went through the process and it was short-cycled or short-changed, and that is not the case. It took us a very long time to get here. And I think the biggest thing was establishing a new paradigm for both small modular reactors and setting the stage for advanced reactors to go through this process. I always like to advertise, because it sounds like it, that NuScale didn't expect to be doing this alone. We expected to be here with multiple other small modular reactor developers, but it's expensive to do that. And some companies and folks are risk averse, so they chose not to join us on that path. And we had to make the business decision of going forward. We just felt it was too important to not push forward, work with the NRC, get the technology approved, which it is, and to be able to move forward for going for the first plant in the US and then globally. But you're right. I think the biggest thing was working with the NRC for a paradigm shift. We're not all the way there for advanced reactors, though NuScale's an advanced reactor technology. It's really not in that generation 4 space. So we set the stage. I'm looking for someone else to take the torch and move forward.
If I can quickly summarize what Erin and Scott said, April. So we've had these rules for licensing reactors develop around this old technology, which was ubiquitous, essentially. But with these new reactors and their unique characteristics, there's many parts of these rules that just don't apply. And so licensing through these kind of obsolete rules is very cumbersome and far too expensive. And so the Congress has actually recognized this, and they have ordered that the NRC create a new rule for licensing those advanced reactors. As I mentioned, it's called Part 53. And that will hopefully, with more comment and work with NGOs like mine, we will help the NRC to develop a rule that recognizes the unique characteristics of SMRs and is much more efficient for licensing them while maintaining very high standards.
One of the things that one of you all mentioned about other SMR companies, Scott, I know, NuScale is moving forward, but how many other technologies are out there right now? And how many are actually in the NRC process?
I'll answer the last question first, because it's an easy answer. How many are in the NRC, let's say the official NRC licensing approval process? To the best of my knowledge, and I talked to our licensing team late last week on this because I was asked by a customer, the answer is 0. And again, it takes an awful lot of investment and an awful lot of effort to advance a design far enough to be able to enter into the process, to be able to prove that you're, again, the safety case across implementation, design, construction, and operation. So right now it's 0. Now, how many other nuclear technologies out there? There are quite a few, and I don't want to leave any short, but there are a number of them from within the U.S. I could think of X Energy, GE Hitachi. There's TerraPower, which is working with GE Hitachi. So some of them are kind of teaming together to move forward. I'll just focus on some of the U.S. folks for now, and I can think of X Energy's in the advanced reactor space, ARC with the ARC 100, Oklo with a micro reactor. They're all really interesting and exciting. However, you need someone to lead. And again, NuScale didn't expect to be leading in this fashion, but here we are.
Yeah,
I'll just follow up, April. I think the light water reactor SMRs are very similar from a nuclear physics perspective, a nuclear fuel, and the neutron moderator, very similar to our operating nuclear power plant. So NuScale certainly the furthest along from an NRC licensing perspective. But the GEH design, they do have licensed a larger ESBWR reactor. Their BWR X300 is a smaller version of a reactor that's already licensed. So I think the licensing path is fairly straightforward. You have Holtec SMR 160, also very similar to operating nuclear power plants. And then if you follow what's going on globally, especially in Great Britain with Rolls-Royce, I mean, they're making pretty significant pathways to deploying the Rolls-Royce SMR, very similar to what we could deploy here in the US. You just have to change the frequency of which the electricity is generated. So I think from the light water reactors, I think they have a clear licensing path. some of the more advanced technologies, it's going to take a little bit more time. And as Scott mentioned, X Energy, Kairos, TerraPower. I mean, there's a bunch that are evaluating these more advanced designs that are getting some pretty substantial funding from the DOE to deploy their technologies.
Oh, I do want to apologize for not mentioning Holtec and Kairos. I do talk to those guys quite a bit, and I apologize for not mentioning them. One caveat with Rolls-Royce, their design has migrated into more of a medium modular reactor space. I think they're in the 470 megawatt range. Not to cast dispersion on what Todd was saying, but as the designs for technologies they advance, there are some elements that start moving into I would say positioning for the market that I would say change a little bit of the focus of each company and the ability to license. So that's something that they have to weigh, measure, and be cognizant of.
And I'll just add, in terms of the global marketplace, we've done a very good job of discussing the players here in the U.S. domestically. I think in 2020, the IAEA put out a report, the International Atomic Energy Agency put out a report that included over 70 commercial small modular reactors and microreactors around the world. So I don't think that included all of the ones that you see at various poster sessions and coming out of universities. These were 70 units that are 70 designs that have some commercial plan behind them. So it's a very high number. And as the panelists have kind of said, the ones that rely on our existing knowledge base and fuel and reactor performance in terms of the light water reactors, those are the ones we'll likely see first. And the more advanced and Gen 4 reactors, it's going to take them a little bit longer to come online. But there's no shortage of designs out there.
Well stated, no shortage.
Well, I want to note that it is 2 o'clock, and I do have a couple questions from the audience, but I want to get into a couple things before we get to those questions, because this has been a great conversation, but it would be neglectful for us to not talk about safety. And as we all know, when we've talked to community members and stuff, that when we're looking at taking a nuclear project into the community, safety is always the first thing that comes up. So how is SMRs any more safe than what we have currently? Are they safer, or is there a difference? I think we just need to really talk about safety when it comes to SMRs.
I'll jump in with that. You're absolutely right. Safety in any nuclear technology is primary, and I almost use the word critical, which is not the right word to use in nuclear discussion, but it's primary and unbelievably important and constantly focused on. So with the advancement of passive safety systems that have been really brought forth by both Westinghouse, the large units, Westinghouse and their AP1000, as Todd mentioned before, GEH with their ESBWR. I think the critical thing is taking a look at those designs and leveraging some of the features that they've included into smaller designs. Example with what NuScale did with its passive safety systems. And one of the things that we really focused on was taking out some of the variability that can be introduced into a situation that can create problems. And so we focused on what we call our triple crown of safety, where there's no operator or control system action, no AC or DC power required, and really no additional water, which is the moderator for nuclear reaction, required for NuScale design. And those are some of the elements. Some of the other designs use some of the same elements. I think NuScale is the only one in I would say SMR space that utilizes all three, and that's why we can use the triple crown of safety moniker. But the goal is to situate a plant so that there's not a lot to worry about in the event of some really odd things occurring. And that's one of the things that gets borne out during the review by any regulator, including the NRC, is what if you have cascading events? And some of them you would say borderline on really crazy. I remember one regulator asking us, what if you had an instantaneous loss of water? not like a leak, but instantaneous. Well, I don't think anybody's ever seen that in any situation where instantly all water is gone within a nanosecond. But we had to prepare for that. And you do the analysis and you prove this is what is going to happen with the plant. This is what the plant will, the reaction is. And the reality is that it's a very minimal impact to the reactor itself and then to the community outside of where the reactor sits. These are the things you need to address. We've addressed them. The new designs are addressing them in some of their own fashions and that, but the focus is completely on safety, safety, safety all the way through.
Just to add on to some of the comments Scott made, I want to make it really clear that our facilities operate safely today. And I would not be a proponent of nuclear power if I had any doubt over the safe operations of our nuclear power facilities. With that said, some of these features, and this is just an example, some of the designs today rely on backup power generation if there's a loss of offsite power. Well, these new designs don't need backup power generation because they can be cooled through natural circulation. So it's those kinds of changes that are being incorporated into the designs that make them walk away safe. And by walk away safe, I mean, if there were a postulated event where something happened, whether it be some kind of event that we lost offsite power, the operators of the nuclear power plant could walk away. And they could walk away for days without having to take any kind of action to maintain the reactor and the reactor core in a safe condition. Natural circulation would cool the facility. All the components would use gravity to have certain things happen. So the fact that there's no need for offsite power, no backup power source, being walk away safe really does take the facilities to a kind of a next level of safety.
Great answers. Thank you, guys. So the next question I want to ask you before we get into audience question, and then I don't want to ignore it. What about nuclear waste, and how does it differ between what we have now and with SMRs?
I'll start, April. With the near-term light water reactor SMRs, I mean, those are using essentially the exact same type of fuel that we use in our commercial reactors today. They may have fewer fuel assemblies, they're shorter fuel assemblies, et cetera, but they're still uranium dioxide pellets in a zirconium tube. That said, from a perspective of how much waste is generated for power output, there can be some efficiencies there compared to comparing the small plants and large plants. If you're load following your plant, you're not going to have as much waste generated as quickly, et cetera. But there's really not much of a difference there. Where we really will see some changes on the back end of the fuel cycle is when we start bringing online some of these Generation 4 power plants that can utilize the residual energy in the spent nuclear fuel from our commercial power plants using light water reactor fuel that can reprocess that fuel, extract that extra energy, use it in a fast reactor system, molten salt system, something to that effect, and actually reduce the amount of material that is involved in the spent fuel chain right now.
Thank you very much. Jon-Michael?
Yeah, I have 3 quick points to make based off of what Erin said. So one, yeah, for some designs, that's true. There is not a large difference in the waste, though there are certainly new designs, SMR designs that will reuse, and I don't like to say waste. I prefer to say spent nuclear fuel.
I like the word byproduct.
Exactly. We're not talking about glowing green stuff. But there will be opportunities in the future to recycle this fuel and use it again. So increase efficiency and things of that nature. So that's one. And then there are also a lot of other private sector innovations that are new ideas about how we can store spent nuclear fuel and tell and when it is able to be used again. Things like deep isolation, and other countries are exploring some of these options. And the third thing I'll mention is that the challenge with storage of spent nuclear fuel is really just about getting agreement and changing some laws so that we are allowed to store it somewhere. That's really the only issue. And organizations like mine are working on that, and we will overcome that challenge. And again, it is an opportunity.
It's an opportunity. I think that's a good theme for this conversation, is opportunity. I'm loving it. So right now I am going to start asking some questions from the audience. And so please, if you have questions, submit them, and I will try to get as many as I can before we have to go. First question: is the biggest barrier for HALEU related to regulation, supply chain, or technology?
Guess I can start with that one, April. I think, my personal opinion, the biggest hurdle is probably supply chain, followed by regulation. I don't think technology is a massive hurdle. There are some technology development things we need to do in terms of, developing and licensing casks for shipping high-assay LEU around and things like that. But that's not really technology development so much as it is just building a new product. I think most of it is related to the supply chain things we need to do. And, there are some regulatory aspects that will have to be addressed. Just increasing the enrichment of the material makes criticality incidents, more likely to happen. You have to put extra controls in place on how much material you have in any one location. So I would say supply chain and regulation are probably the two biggest barriers right now.
Great. Well, I'm gonna leave you with that answer. I'm gonna go on to the next question because my little board started popping up, and it I got a few questions that we need to get in before the end of the hour. In a state like Virginia, with its wide range of topography and its varied population bases, what are the SMR site selection challenges, and how many sites will be required in Virginia? Todd.
Yeah, so I'll take that, April, because I'm leading the team that's looking at sites all across the Commonwealth. And we have a lot of opportunity, as you mentioned, that another key word. So, certainly existing operating nuclear power plants offer an opportunity to place additional nuclear generation facilities. We typically have excess land at those facilities. There's already site security. There's already access to the grid. But a critical, important place to look is also at our coal generating facilities and other fossil fuel sites where facilities have either been shut down or will be shut down. Those coal generating facilities offer a point of interconnection facilities. They often offer a source of water for cooling. So there's intake structures. They have a workforce that is ready and willing to transition from a job in the fossil fuel to the nuclear. So certainly the site of coal power generation facilities are ideal. Also other brownfield or industrial areas make very ideal sites to place an SMR. And we're looking at all of those options across the Commonwealth as potential sites. The beauty is that the footprint of these facilities is significantly smaller than your traditional plant, as I mentioned earlier. So, ideally, if you're looking for 50 acres up to 200 acres, there are a lot of sites that are open up for potential for placing SMRs. As far as the number, if you look at our integrated resource plan, there could be many SMRs that we're evaluating, up 15 within the next 15 years. I expect you could see these come online as soon as the early 2030s. But significant opportunity across the state. A lot of these facilities are subsurface, so there'll be some grading required, but that's certainly not a significant challenge. So you will need to grade a site so that you can build the reactor kind of primary side of the facility partially below grade. But really, I think Virginia is uniquely positioned given the number of coal sites, given the number of industrial sites, given North Anna and Surrey having such large footprints that can accommodate multiple units. I think there's a lot of opportunity to place these in many different locations.
Thank you very much for that. The next question. Two of our country's most advanced energy systems, nuclear and hydrogen, are on a real hot streak lately with the passing of the IRA and the pilot demonstration projects like those being pursued by Bloom Energy and Westinghouse or Davis Best and the Idaho National Labs. Given Virginia's leadership in nuclear and hydrogen hub put forward in the DMV region's greenprint, what do each of you believe to be the potential opportunity and leadership roles in the state for peak hydrogen? Who wants to start that one?
I'll start with that. First, and this is one of the great, value additions of small modular reactors, is that they, as I mentioned, have this, more diverse range of applications, and one of them is hydrogen production. And nuclear is great for hydrogen production because it can offer not only firm power, electricity, but also high heat. And what that will do is unlock these more advanced and efficient hydrogen production techniques. And those will also make it more economical to operate hydrogen production. So nuclear is going to be really important for, unlocking this additional renewable energy source in hydrogen. And as far as opportunities in Virginia, as Todd mentioned, there's going to be a lot of opportunities around coal sector potential, and I think that's probably the first place to look. But I'll let the others explain.
Now, just a comment that if you look at the technology that's being deployed for hydrogen production, those electrolyzers are very expensive to build, and you're going to want to operate those around the clock. So it's difficult to envision using renewable generation for hydrogen production because you're not going to get around the clock energy to produce hydrogen. So I think that SMRs, and given their ability to be a base load power source 24/7, and given the cost associated with the electrolyzers that are needed to produce hydrogen, the marriage between SMRs and hydrogen production creates a very unique opportunity. Coupled with that, with the IIJA and the IRA, those incentives can be multiplied. So for example, you can get incentives for putting an SMR in a clean energy community. You can get PTCs or ITCs. And then on top of that, there are additional credits that are available for reactors that can generate clean hydrogen. So there's an economic pathway to deploy kind of the marriage between those two technologies.
Yeah, just real quickly comment, April. To me, the coupling of nuclear and hydrogen generation is the biggest opportunity for nuclear and SMRs, just in keeping with the theme that we have today of new opportunities.
And I could not agree more. We've done quite a bit of work in that area, and we're looking forward to going into the implementation phase to support it. We're ready.
Thank you all very much. What is the time frame do you think we'll actually have an SMR up and running?
I'll take that one. NuScale's first plant is scheduled to go online for commercial operation in 2029. The plant is going to be owned by the Utah Associated Municipal Power System. They've been deeded a site in Idaho at the Idaho National Lab facility, humongous facility. And that project is progressing on schedule for UAMP's needs, and it's a conglomerate of owners, and to meet their needs for their projected load growth. We do have the ability to speed that up a bit if that load growth projection moves forward a little bit, and if California starts asking for more power from them. To support that, again, I mentioned very early on here today that our manufacturing capacity buildup is delivering prototype and really manufacturing planning and the initial NuScale power module production. We will be having those NuScale power modules coming out of the factory in late 2026, early 2027. So really in that November 26 to January 27 timeframe. And it's not a matter of producing the reactors or the fuel or the components. It's a matter of constructing the facilities to install them in. So we could be ready for implementation If you started today, 2028, we can be in commercial operation phase.
I would add, April, that there are a few other advanced reactor vendors, small modular reactor vendors, through the Advanced Reactor Demonstration Program that will begin operating in similar timeframes, including some internationally. But even on a shorter time scale, we will see microreactors coming online in the next maybe 2 to 4 years, and those are technically, in a different category than small modular reactors, usually less than 10 megawatts. But as those come online, they will prove the case and also help build the supply chains for small modular reactors, and that'll I think really increase.
Thank you. I appreciate that. Next question from the audience. Are the existing shuttered coal mines in Southwest Virginia considered potential sites for SMRs with their available natural source of water? Todd, I believe that'll be you.
Yes. Yes, certainly, Southwest Virginia, not only the coal mines themselves, but sites where coal processing was involved. I mean, that quadrant of the Commonwealth of Virginia has been a leader in the energy production process for decades. And as we transition to clean energy, I think it's important to recognize their contribution to energy and to make sure that they get the same kind of economic benefits and job opportunities that SMRs provide. So it would allow for a just transition to clean energy. Those sites are very ideal. There are excellent sites in Southwest Virginia that have access to our transmission system. Brownfield sites certainly are an excellent opportunity to deploy SMRs.
Thank you. So we're rounding up our time. We have about 9 minutes left, but I want to ask each of you guys to take a few minutes. This has been a great conversation. So enjoyed all the information you guys have provided. But I'm going to start with you, Jon-Michael. What would you want the audience to walk away from today on this topic?
Well, thanks for letting me go first. I would say this: optionality as we strive to meet the demands of climate change and a modern society will be crucial. Optionality. And that means we include all available tools at our disposal, including small modular reactors. And for a Virginia perspective, I think if you want to try to enable that in optionality, the best thing to do whenever you're designing policies is to create a favorable environment for all carbon-free energy sources to thrive. That's not only going to boost economic activity and help achieve these goals, but also going to really benefit Virginia's communities, especially around those coal communities.
Thank you. Erin, I'm going to throw the same question at you.
Well, thank you, April, and thank you for moderating today. I thought the panel was excellent. Let's see, the takeaway from me, I think the key takeaway for me, or that I would like people to recall is, in my mind, any electricity grid in our nation should have 3 major characteristics. It should be clean, it should be reliable, and it should be safe. And although I'm a proponent of renewable energies, they are not reliable, right? The wind doesn't blow sometimes and the sun doesn't shine sometimes, right? It's the only power source we have as a society that is clean, safe, and reliable is nuclear power. I think there are tremendous opportunities within the state of Virginia and across the nation for small modular reactors to come on and support that diverse power supply as we move away from fossil fuels.
Thank you. Scott, same question.
So I do want to reiterate something that Erin said, which I think was really important, was that this was a great panel today, and I actually learned a lot from each of the other panelists. So I thank you for that, and again, thank you for the opportunity. I also agree with the concept of optionality and the opportunity for moving forward with nuclear energy, particularly in Virginia. Virginia is an interesting state, really poised to be able to move forward and take advantage of the opportunities of multiple clean energy sources, including nuclear energy. I think the biggest thing that the takeaway today is that there is that opportunity, and I would ask folks to make sure that they're talking with their representatives and saying that we really think we need to do this, and let's take advantage of the existing capabilities we have within the Commonwealth to do that. BWXT, Framatome, a number of others really are poised to move SMRs in Virginia. Think about it, it's not just moving forward on the national stage, it's moving forward on the global stage. And if we can lead that effort, think about how important that is to really reducing the carbon footprint globally. I think there's an opportunity, we need to take advantage of it.
Thank you. Todd, your question is going to be a little different. I do want you to answer about what what do you want people to walk away from this conversation today? But I also want you to ask, why is Dominion considering SMRs?
Yeah, and in some ways it's the same response. So, what I want people to take away is just to recognize that we're in the middle of an extraordinary transition. Personally, I'm very honored to be a part in my company's deployment of solar. And because of these efforts, Dominion Energy is the second largest solar fleet in the US among utility holding companies, second in the country. That's pretty amazing. But also it's to recognize that our nuclear fleet produces 90% of our carbon-free resources. And that fact is just demonstrates the need for nuclear to be a part of our carbon-free fleet, and going forward, how we need to plan for new nuclear to be a part of really decarbonizing the grid. And why is Virginia looking at SMRs? And we've kind of chimed in on this already, and it's because we look at SMRs as being a source that's complementary to the other carbon-free resources that we're deploying, complementary to offshore wind, complementary to both utility scale and distributed energy. As we do our long-term planning, we know that we need something else other than just renewable resources, and SMRs can be deployed in an economic fashion. We think it's going to be the most economic resource if you need a firm delivery of energy. So it's not too soon to be looking at what's going to be coming online within the decade. The time is now. We're investing today, looking at sites, evaluating various technologies. So as part of our long-term planning process, it's recognized that nuclear has got to be part of the equation.
Thank you. I want to plug in one more thing. I'm going to mention that we've talked about opportunity. We talked about why Virginia is unique. Virginia is also unique because we're the only state that has a strategic plan for the nuclear industry. This is something the industry has provided the state. That also puts us in a very unique position because we keep looking forward and looking at opportunities for the future. I also want to thank the Virginia Energy Renewable Alliance for having us today. I really appreciate this opportunity. And thank you all for joining us. Any last words, gentlemen?
I'd be remiss without mentioning our state-of-the-art port. So in addition to all of the nuclear infrastructure, we do have one of the best ports in the country. So all the more reason to bring new technologies to the Commonwealth.
Agreed. Anything else, gentlemen?
Thank you very much for having us on the panel. It was a great experience.
Yeah, thank you, April, and gentlemen, nice talking with all of you.
Yeah, likewise, thank you for the opportunity, and gentlemen, it was great being on a panel with all of you today. I really felt that we synergized well. Well, thank you.